physics. Do you like them? Like in games or simulations? Well, I sure do. When I say physics, I don't mean this. Well, I certainly do, but would you like to create physics-based simulations without writing those cryptic death threats? I got you covered. Therefore, welcome to my lesson on how to use physics in Unity. Unity is a game engine that is powerful and comparably easy to use. To show that, I will guide you through just a few topics. Time is limited, so grab your free installation of the Unity software and let's begin. First off, let's talk about some basics. This is Unity. The hierarchy view over here displays every object in your game. We conveniently call them game objects. You can create a new object, let's take a cube for now, and look at it in the scene view. Every object has components attached to it. You can edit them in the inspector view. They affect how an object will behave. Standardly, the transform component holds things such as position, rotation, and scale of the object. Now let's add the physics to our object. In order to do that, you go to Add Component. This will give you a list of many different behaviors an object can have. Then select Rigidbody. You can configure many things here, but we'll get to that in a minute. First, you can hit play at the top and see how it works. As you can see, the cube now falls. Go ahead and stop the game. Every change happening during play mode will be reverted afterwards, so don't worry. Oh, by the way, you can see the camera over there. Click on it to see the boundaries of its vision. Move the cube further to the middle to align it to the camera's view field. This way you can ensure the camera sees the cube well. Copy the cube, move it down and scale it on the X and Z axis. This will be a platform for the cube to fall onto, but currently the platform will fall as well. To solve this problem, just remove the Rigidbody component from the platform, because this actually tells Unity to compute physics on this object. But how does the cube know that it's a cube and where its boundaries are? Well, you actually have to... What the f was that? Oh, this is actually a good example. You can see the chicken here, right? It's rolling as if it was a ball, but it's obviously not. That is because you have to differentiate between the only visual mesh and the physical collider beneath. A mesh is what you can clearly see right now, but the collider looks more like this. That explains why the chicken can roll like a ball. This is how Unity handles physical collisions. An object can have a collider component attached to it. It tells the object how it should react to its environment. This specifically is a box collider. We can remove it and replace it with a sphere collider. Let's rotate the platform a bit and see what happens. Now a Rigidbody has many properties, as you can see. The object should be heavy, raise the mass, but be aware that mass does not affect the fall velocity. The object should be feathery, raise the damping. Linear affects the positional velocity, while angular affects the rotational velocity. Center of mass should be pretty obvious. Tensor is essentially mass, but for rotation. Use gravity is a no-brainer, but it still uses physics. Kinematic is literally too much for this video, but this essentially means an object can be manually controlled and triggers collision callbacks, but cannot be manipulated by external forces. Same goes for interpolate. Unity uses 2 timelines for each gameplay and physics. This would also go beyond the scope. Detection controls the detection of collisions. Well, who would have thought that? These are different levels of detection. They all have to do with fast-moving objects. Constraints are pretty straightforward. Freeze position freezes the position, freeze rotation freezes the rotation. Congratulations, you've just successfully speedrun the basics of Unity physics! This was just a brief little overview of Unity as a software. If you want to dig deeper to know and learn more, I highly recommend Breckies. You can check him out on YouTube. As you saw in the middle of the video, you can definitely do much more than just physics with Unity. In fact, everything you saw in this video was purely made in Unity except for the models. Every weird little thing placed down, hell, even the canvas and all its features were made here. Unity has an animation tool along with a timeline for cinematic purposes. Well, this was intentionally meant for cutscenes. I don't care! I hope you learned something. Or I at least caught your interest in trying it out yourself. However, thank you very much for watching. I wish you have a great day and stay safe. Jesus Christ, I need a break.